So today we're really just exploring Euclid's fifth postulate and what it means for lines and angles. On Monday we'll apply it, okay? So our learning target for today is I can explore the angles determined by two lines that are intersected by a transversal. Okay? That's what we're going to be talking about today. This is Euclid's fifth postulate. So let's go ahead and write out the postulate, and then we're going to talk about what it means, and we're going to start applying, just exploring the angles that are formed by these types of lines. Okay, so Euclid's fifth postulate. Okay, so given any straight line and a point not on the line, there exists one and only one straight line that passes through the point and never intersects the line. Okay, so I know that's a lot, so get that down, and then we're going to draw a picture of what that looks like. Okay, so once you have that definition down, I want you to try to sketch out what it says. You may want to use a pencil just in case you want to erase it. But the postulate says, given any straight line, so you're going to want to draw a straight line. And a point not on the line. So you're going to want to put a point that is not on that line. And then it says there exists one and only straight line that passes through that point and never intersects that first line. Hello? It's on our way. Okay, okay. Okay. So go take a second real quick and draw what you think that that's saying, and then I'll draw it too, and we'll compare our pictures. See you Monday. You too. So you have a line. You have a point that is not on the line. So maybe right here. And this postulate says that there is only one line traveling through that point that will never intersect this other line. So I'm going to draw that in. Any other line that travels through that point will eventually intersect that other line. Okay? So if this line is just slightly off of this line, eventually somewhere down the road it will eventually intersect. Okay? There's one and only one line that will never intersect that other line that passes through that point. And this is why we call this the parallel postulate. So it's Euclid's fifth postulate, but we also sometimes call it the parallel postulate. So I'm going to put AKA, the parallel postulate. You'll hear it referred to that as well. Okay, so now comes the fun part. We're going to explore these angles that are created by parallel lines. So let me get an example going here. You're going to want to just try to make your lines as, make your picture look as much like mine as possible. It will help you so that you have a good representation in your notes. Goodness, you guys gotta speak up sooner. And if I don't see that that's showing, then I'm definitely not gonna see your hand raised trying to tell me that it's not showing. So you just gotta say, Miss Mac, move it up, and I'll move it up. Bless you. I'm gonna put a few points on here too for the triangle, and then also on the line, just so we can discuss some of these angles. Okay. I'll get your picture down, and then we're going to discuss this. All right, so we're going to just kind of talk about some of the things that are happening here, some of the angle relationships, basically. So does anyone want to share anything about these angles, any relationships that you see? We've talked about a lot of different types of angles. We've talked about supplementary, complementary, adjacent. We did the angle sum theorem. We did the exterior angle theorem. Yeah, Pranav. Oh, share it out. Nobody else is raising their hand. Go for it. What's that? I'm sorry, what? What was the question? How are the angles related to each other? Or can you see any angle relationships? No? Maddie?
This is probably the smallest thing, but since it's triangles, 180, the line is also 180.
Yeah, so are you talking about the interior angles here? That's a really good observation, because you have these are supplementary. They added to 180, and then the angles inside added to 182. Anybody else? Macy? Yeah. Okay, so there's an exterior angle right here. That exterior angle is equal to the sum of the measure of angle 2 and 3. Good. Anything else? Yeah, Trevor.
There could be a fifth exterior angle from number 3.
Yeah, definitely. This is it's not labeled, but this could be an exterior angle, and the sum of this angle would be the measure of angle 1, or sorry, this measure would be equal to the sum of angle 1 and angle 2. Yeah, good. Anybody else? Well, I know Maddie touched on it. These are supplementary, so these add up to 180. These angles are supplementary, so this angle out here is also going to be plus angle 3 will be 180. These three angles together would be 180, right? Okay, good. Now we're going to do some exploring. So what I'm going to do is I'm going to extend these lines a little bit. Okay, right off the bat, do we see can we identify what angles would be equal to any other angles? Kareem?
2 is congruent with B.
Yeah, so yeah, I would say these two are vertical angles. So if this has a measure, if this angle it has a measure of 2, or this angle 2 would be congruent to this angle 2. So I'm just going to put a 2 there to say that those are the same. Yeah, Trevor?
It also creates supplementary angles for line M.
Absolutely. There's supplementary angles happening all over the place here, because these 3 are supplementary, these 3 are supplementary, these 3 are supplementary. All the way around that is supplementary. Okay. So now here's what I'm going to do. I'm going to sketch this angle on patty paper. So patty paper is literally the paper that they put between hamburger patties so that they don't stick to each other. But it's perfect for this because you can see it's nice and transparent. So I'm going to draw this angle, angle 3 right here. You're going to be using patty paper a lot next year in your math class. Okay. Now, I know that this angle is 3, right? Now, if I were to slide this angle along this line, ooh, yeah, you're going to see that lines up perfectly. Lines up perfectly. So we can say that these angles are congruent to each other, right? That's the fun of parallel lines. All kinds of fun things happen with parallel lines. Okay, let's do the other one. I'm sure you guys can already guess what's going to happen, but that's okay. It'll still be fun to see it happen. Okay, so this is angle 1 here. And if I slide it along, So we can say that this angle right here is congruent to angle 1. All right. Now that we've done that, are there any other angles that we can label? Like what's this angle right here? Awesome. What's this angle right here? Sweet. Okay, so I just, actually, also, since this is an exterior angle, we could say that this angle right here is T1 plus 2. Right? All right, so we were just exploring today. On Monday, we're actually going to be applying this, okay? You guys can get your notes filed away.